All right, let's talk about one of the most hyped up and honestly confusing technologies out there, blockchain. We're going to cut through all that noise and make it super simple by following the entire journey of just one single transaction, from the moment it's created to the second it's locked into history forever. Ready? Let's dive in. So, at its core, blockchain was built to solve one huge problem. Think about it. In the digital world, anything can be copied, deleted, or changed. So how can you possibly prove that a payment was really sent or that a vote was really cast without a central party like a bank or a government to verify it for you? That is the big question. And to see exactly how it answers that question, we're going to put on our explorer hats and follow one little transaction step by step, all the way from its birth to its final permanent home. Okay, so where does it all begin? Well, everything that ever happens on a blockchain starts its life as a single transaction. It's the fundamental building block of this entire system. Now, before our transaction can even dream of getting on the blockchain, it's got to pass a few checkpoints. It's a clear three-step process. First, it's created and digitally signed. Then it's broadcast, kind of like shouting it out to a huge crowd of computers. And finally, those computers all get to work verifying that it's legitimate. So how in the world do you sign something digitally? Well, it's done with this brilliant thing called public key cryptography. You use a secret private key, something only you have, to create a totally unique digital signature for that transaction. Then anyone out there can use your public key to check that signature and prove without a doubt that it came from you. It's basically an unforgeable, tamper-proof digital seal. Our transaction is signed, sealed, and ready to go. Now it gets sent out into the world to face what I like to call the great network test. So it's broadcast to a peer-to-peer or P2P network. This is totally different from the normal internet. There's no big central server owned by a company. Instead, every computer or node on the network talks directly to its peers. It's a beautiful design, really, because it means there's no single point of failure. The network is incredibly tough. And this network is made up of all these different computers, these nodes. Some of them are the heavy lifters, often called miners or validators, and they're the ones who do the hard work of checking transactions and adding them to the official record. You can think of them all as the guardians of the system's integrity. But this brings us to the next massive challenge, right? If you have thousands of independent computers scattered all over the globe with no single boss telling them what to do, how on earth do they all agree on which transactions are valid? How do they all arrive at the exact same version of the truth? They do it using a set of rules called a consensus mechanism. The two most famous ones are proof of work, which is what Bitcoin uses, where miners compete in a race to solve a really hard math puzzle. The winner gets to add the next batch of transactions. Then there's proof of stake, where validators put their own money on the line, like a security deposit, to prove they'll be honest. They're just different roads to the same destination, getting everyone to agree. Our transaction has now passed the test. It was created, signed, broadcast, and validated by the whole network, so now it's time for the grand finale, forging its place in the unbreakable chain. The network doesn't add transactions one by one. That would be super inefficient. Instead, our verified transaction gets bundled together with a whole bunch of others that have also been approved. This bundle is called a block. It's like collecting a bunch of pages that are all ready to be bound into the next chapter of a book. And this, right here, is where the magic happens. Every single one of these blocks gets its own unique digital fingerprint, which is called a hash. And this hash is the key to everything. This is what creates the chain. See how that works? Each new block includes the unique fingerprint, the hash, of the block that came directly before it. This creates a direct cryptographic link, chaining every block to the one that came before it, all the way back to the very first one ever created. So what exactly is this hash? Well, it's the output of a mathematical function that takes all the data in the block, including our transaction, and spits out a unique code. But here's the crucial part. If you were to go back and change even a single comma in our transaction, the hash for the entire block would change completely. It's that sensitive. And that leads us to the most powerful feature of a blockchain, immutability. Because each block's hash is baked into the next one, you can't go back and secretly change an old block. If you tried, its hash would change, which would break the chain for every single block that came after it. The fraud would be instantly obvious to everyone on the network. Our transaction is now permanent. So our transaction is now permanently and securely recorded.
Now that we understand the mechanics, let's zoom out a bit and see what this technology is actually used for out in the real world. One of the most mind-blowing developments is the smart contract. This is basically just computer code that lives and runs on the blockchain. It can automatically carry out the terms of an agreement. For example, a contract could automatically release a payment to a delivery company the exact moment a tracking number confirms a package has arrived. No lawyers, no middlemen, just pure automated trust written in code.
And it's really important to remember that this isn't a one-size-fits-all technology, not at all. There are public blockchains like Bitcoin that anyone in the world can join. There are private ones controlled by a single company for their own internal records. And there are consortium chains shared by groups of organizations, like a bunch of banks working together. You've probably heard people talk about a 51% attack. This is the main theoretical weakness. The idea is if a single person or group could somehow control more than half of the entire network's computing power, they could potentially rewrite recent history. But on big, decentralized networks, getting that much control is incredibly difficult and mind-bogglingly expensive. And that difficulty is the very heart of its security. Whew, our journey is complete. We followed our little transaction from a simple digital signature all the way to its permanent home as an immutable record. So let's wrap up and talk about what this all really means. If you remember anything from this, remember these three things. First, transactions are secured right at the source with powerful cryptography. Second, a decentralized network of computers all agree on what's true using a set of rules called consensus. And third, these verified transactions are bundled into blocks that are chained together, creating a permanent and tamper-proof history.
Ultimately, the journey of that single transaction reveals something pretty profound. Blockchain is a technology for creating trust and agreement in a digital world where that's really hard to do. It's a way to actually program trust directly into our systems. And that leaves us with one heck of a final question. Now that we can do that, what are we going to build with it?